My name is Kevin Dupont, and today the focus is on enclosed space and basement ventilation. What we can put in place to make effective basement ventilation work for us. Make areas of confined or restricted space, things like basements, undercrofts and so on, a safe environment to be working in. So why do we need to have ventilation in basements? You may remember, or I remember a couple of years ago, there was a piece that the BBC did on, it was actually related to capital punishment, would you believe? And they were looking at ways of how oxygen depletion can be used to that end. And they put this guy, it was actually Michael Portillo, they put him in the chamber and started reducing his oxygen supply. And at first there was no problems at all, everything was going fine. So they started to reduce oxygen even further and start to ask him simple questions. Something like, what's 2 plus 2? And he was coming back with something like 5. So they asked him, are you feeling all right, Michael? Yeah, no problem at all. Absolutely fine, no issues. So they decreased the oxygen even further and repeated the process. And every time he said it was absolutely fine. But he had no idea of the gravity of the situation. Now, this sort of environment could be exactly what it would be like in a basement if you had asphyxiants like carbon dioxide present, which would actually reduce the oxygen in the air. And you wouldn't even know about it. Once you get to a point of having an idea there's an issue, it'll be too late. That is really why we need to look at effective ventilation if we're working in confined or restricted space. It can have an immediate impact if we're in that environment and the oxygen is depleted, but also it can cause long-term health effects if you are fortunate to escape from that environment. It can cause lung cancers and other cancers as well. So they're obviously dangerous places to work. Anywhere that's confined or restricted, you've got a lack of oxygen, but can be because of actual processes that are going on. It could be because of the amount of personnel working in there. All have to be factored in when we're putting in ventilation. It could be other processes like cutting or welding, using oxygen up. Diesel plant, also using oxygen up. We need to factor in all these type of activities that are happening in this confined space. It's not just about providing oxygen in there. If you're in an environment, perhaps you need to go into a confined space and just do a survey of some type, then we just need to be factoring in the amount of personnel in there, each requiring oxygen. It really becomes a major issue when we're looking at other processes, which typically would happen in a basement, for example. So what can we do about it if we're looking at a basement project, whether it's just to do a survey or do some breaking or excavate out a basement in the first place? First key thing we need to look at is identify the type of activities. What activities are actually going to have an effect on the amount of oxygen in there? We also need to look at calculating the size of the area. How big is it? Make a volume, understand the volume. Calculate the air changes required. Now we can do this by referring to the British Standard 6164, which actually factors in the amount of kilowatts that are being used in that environment, the amount of personnel working in that environment. Then we get to that point, we can understand how many times we need to turn the air over. And that way we can spec or understand what fans we need to use for that. Identify the access points. Where can we actually get your fresh air supply into that basement? Calculate the distance to surface. How far from the fan to where you need the air to be is that distance? How far is it? If it's a long distance, or the longer it is, the increased pressure on the system, it has to be factored in. Imagine trying to blow through a short length 2 inches of, say, garden hose. Quite easy over 2 inches. But say that was 2 foot long. You can imagine how much harder it is to get any air out the other end. Same applies when you're running ducting into that confined space. And then you can calculate the pressure drop and make sure your fan that you're using to provide your ventilation has the power, not just the airflow, but also the pressure to get that air to where you need it to be. So when we look at ventilation in a confined space like basements, there's 2 ways of doing it, either to supply air in or extract air out. Supply air in is by far, and in most cases, the best way to be ventilating that confined space. 4 images here you can see on the screen. If you start at the top, an extract system, a fan on the surface, short length of duct dropping into that basement, trying to extract out foul air. All that is doing is a short circuit. If it's doing anything, it's drawing fresh air from outside, down in a short distance, and then straight back to atmosphere. You can see in the bottom left-hand corner of that image, the dead areas around the actual process. If you go on to the top right-hand image, they've got longer length of duct coming right to the source. Now, that is extracting some of the fumes out from the process. And by nature of extracting air out, you will get make-up air in to give you the air change. But how much? You have no way of knowing really. Is there a natural way for that make-up air to be drawn in? And if so, is it big enough? There could be a hole at the other end of your basement for that air to come back in behind. But without understanding the size of it, you can never be certain of the amount of air change. So the extract idea tends to create dead areas and doesn't give you a full ventilation of that confined area. There are some situations, however, where they can be good, which I'll come on to in a moment. The bottom left-hand image is a supply idea of ventilation. You can see the ducting dropping in and it's going towards where the source of the fume is. The idea being to purge out the basement. So new air comes in, gives you fresh air, and it pushes the dirty air back to atmosphere. But the problem with that, it's only doing half a job. It's important to get, as you can see on the bottom right-hand image with the tick, the ducting and the fresh air as far away from the outlet as possible. So you're getting full air change over the whole environment. You're taking the fresh air with the oxygen right to where or beyond where the actual source is. And that way you can clear the whole of the fume and dirty air to atmosphere. The only thing you need to be aware of, as I suggested a moment ago, with the supply idea, you are putting a positive pressure in there. So there's a potential, if your basement is linked to other properties, for example, you could be pushing dust and fume into those environments. So it's worth bearing that in mind. But generally, supply is a much better way. If you consider extract, you may be digging a basement. How do you know what's in the soil? What gases are in the soil? Could be methane, not only explosive, but a simple asphyxiant. So it can deplete oxygen. Could be ammonia. Could be all sorts in there. Radon, seen that before. If you're extracting out of that basement, you could be drawing those gases up out of the soil you're digging and make the situation worse. So it's much better to look at a positive pressure solution than extract. Top-down construction. We find a lot of this in London now, where they're digging down under a slab, halves the construction time in a lot of situations. Somebody could be digging the basement, somebody could be doing the upper floors. What they do there is they create a cast of concrete ground floor slab, and they leave a mole hole, a small opening, which they can dig down underneath. So it's a great way of speeding up the build process, but it's obviously a very, very challenging environment to be working in. So what we would do in that situation there is have a fan on the surface, like on the previous slide, providing a forced air ventilation right in to the basement. What they typically do from there is cast a basement slab and another mole hole and dig down, sometimes multiple levels into the ground. Each level needs a positive pressure of fresh air to displace any fumes and provide oxygen into that environment. Just a case study that we worked on a couple of years ago at the Scalpel. We've probably seen that building in London. And on this situation, they had a basement that was 6,000 metre cube. And to create that basement, they had enough diesel plant that equated to 160 kilowatts of power down there. So based on those factors and the personnel working in there, we determined that 30,000 metre cube an hour would have to be provided under a forced air ventilation system to dilute the fumes that were down there and provide that oxygen to make it a safe working environment. And that meant putting 2 of our larger 450 CF fans, each with 24 meters of ducting on. So quite a lot of pressure on the system. And that's why we had to use the centrifugal fan in that environment. So when we're looking at hazards, we've probably seen this before, the 3 C's, capture, contain, and control. Absolutely vital for dealing with any hazard. Now, when we're looking at capture in this situation, it goes back to what I said at the earlier slide. Identify the processes that are causing oxygen depletion in that environment. It could be cutting, welding, diesel exhaust. So dealing with those type of hazards at source is what we look at as regard capture. Contain. If you work in an environment and there are a basement and there's neighbours next door, we need to be ensured that we are containing that fume within that environment. And control, making sure you've got the fresh air supply to provide the oxygen, to dilute any gases that are built up, ideally under that positive pressure or that purging principles we spoke about earlier. So the type of fans that we would provide, on the left-hand side, an actual fan, on the right-hand side, a centrifugal fan. On the actual fans, they typically move large volumes of air, but over shorter distances. So, i.e. against less pressure. So you can put short ducting in, move huge volumes of air, but you can't put lots of bends on the ducting, you can't put any filtration on the ducting or limited. Over against the centrifugal fan. Now that moves less air, but against much higher pressure. So you can put even 80 to 100 meters of ducting on because it's a high pressure fan. The centrifugal fans are very good for, or essential really, for handling any volatile gases. If you're trying to move any gases that could be volatile, it's vital you look at the centrifugal rather than the actual type of fan. So some products that we would provide in these type of situations. If you're looking at diesel exhaust, we go back to the 3 C's, the capture, using a particulate filter attached to the exhaust pipe. Diesel exhaust comes under COSH, so it needs to be managed at source with a filtration system. If you've got other processes like welding, cutting, you can use a LEV system to be able to pick up that fume at source and filter it, or even take it to atmosphere. So these are the type of products that you can see on the screen there that are LEV systems designed to capture the hazard at source and deal with it and improve the environment, along with that ventilation that we looked at. Okay, so that's really brought me to the end. I think the key thing is that we assess the situations when you're looking at basement work and understand really the processes that are going in that confined environment, and make sure we have the LEV in place, but also have that ventilation provided, ideally on a positive pressure purging principle rather than the extract. But really it comes down to assessing it and understanding exactly what you're doing and making sure the fan is capable of providing the fresh air, even if it's under high pressure. But if you need any further information or indeed site surveys, there's a number there on the screen. Please call us and we can do a free of charge site survey. If you're tendering for work and you need some ideas on cost, because there can be a significant cost attached to doing this properly, engage with us at that stage. Just call us on that number and we can have an engineer talk to you and go through what we said earlier, assessing the situation. If you need any more information, go onto the website info@rvtgroup.co.uk. There's a whole range of white papers, case studies, toolbox talks, best practice ideas that you can pick up and use. And any further information or details on the actual equipment, then www.rvtgroup.co.uk.